Уважаемые коллеги, добрый день. Я думаю, мы можем начинать нашу конференцию. Меня зовут Андрей Шенин, я вице-провоз по науке в университете Нархоз. И я благодарю организаторов за приглашение быть модератором этого замечательного мероприятия. Я рад всех вас приветствовать на заключительной конференции, отчетной конференции под названием «Природные решения для отходов горнодобывающей промышленности от исследований к практике». Наша конференция посвящена завершению прикладного исследования, проведенного Институтом устойчивого развития Казахстана университет Нархоз совместно с компанией «Алтын-Аукас». А я не буду забегать вперед, наши коллеги подробнее, исполнители этого проекта расскажут про исследование подробнее. Я лишь скажу, что у нас сегодня присутствует международная команда экспертов, которые расскажут не только про ход проекта, но и про его влияние на общество, про его экономическую составляющую, и вы сможете задать им вопросы. Я прошу вас писать вопросы в чат. Также у нас есть перевод, у нас есть стрим на YouTube-канал. Вы можете в чате также увидеть ссылку. Мы проработаем с вами 2 часа.
Seems Andre's frozen, so just give him a second to reconnect. Probably bad internet connection. Okay, so Alashir, Andre is going to be connecting with another computer, so please explain about the translation and the technical issues related to the event, please.
Okay, thank you, Brandon. Уважаемые гости и участники, как вам известно, наши спикеры будут презентовать на 2 языках, на русском и на английском, поэтому в соответствии с тем, чтобы вам было удобно, вы можете использовать функции переводчика. Пожалуйста, нажмите на иконку в форме глобуса и выберите язык, на котором вам удобно будет слушать. Также, если вы хотите слушать только непосредственно переводчика, нажмите кнопку «Замьютить оригинальный звук». Также убедитесь, пожалуйста, что ваши имена написаны правильно. Also, dear guests and speakers, regarding to the comfort of your listening, we also have services of a translator. You can put on the globe button and choose the language which is more useful to you to hear. And also you can mute the original sound if you would like to listen only to the translator. And also, please make sure that your name is written properly and correct.
Thank you, Alashir. And while we're waiting for our moderator to reconnect, I'd like to give the opening speech to Mr. Miras Daulenov, who is the president of Narhos University, to give his opening comment.
Thank you, Brandon. Dear colleagues, partners, and students, I'm very happy to welcome you at the conference and would like to emphasize the importance of the ESG agenda for our university, for Narhos University. We believe that in positive and fruitful collaboration among stakeholders in Almaty and the country of Kazakhstan generally, government, NGO sector, industry representatives, and academic institutions. As part of our commitment to improving the life of citizens, we have approved sustainable strategy in 2019, and we are working hard to further develop and implement it. As evidence of our commitment to sustainability, for several years, Narhos University participates in the Times Higher Education Impact Ranking, which assess our activities across 17 UN sustainable goals. We were ranked as the top 3 universities in 2022 and the top private institution in the country in the same year. ESG agenda runs across our educational curriculum and university life. The new campus of Narhos University has been proved to decrease the emission in the atmosphere and will utilize only eco-friendly materials in the redevelopment project. We are also proud that it has been brownfield project, making it safer to the environment. A beacon and uniting front of the ESG agenda at Narhos University is Sustainable Kazakhstan Research Institute, headed by Brenda Dupre. The institute conducts multidisciplinary research, completes large grant projects, and steers the development of sustainable decisions in the university ecosystem. The work of our institute has been evaluated internationally as a good practice within the scope of the United Nations Economic Commission for Europe's Convention on Water and Industrial Accidents in October 2022. ELSA, nationally during the working group on the talent safety and prevention of accidental pollution in Kazakhstan in February 2022. Our concrete example is the work on the improvement of air quality in urban and industrial environments through a process called phytocapture. This approach uses various generation types, such as trees, to disperse and capture toxic dust coming from industry and fossil fuel burning vehicles. Using advanced computer modeling, experts model plant surface atmosphere interactions concerning the outdoor environmental with various pollution types such as dust. Using the model, they support city governments and businesses to examine the best location design and plant combination needed to reduce pollution, heat, gases, and can significantly illustrate the improvement air quality through such designs. This work was not only conducted at Aksu mine, but also at our university during the reconstruction project. I would like also mention that recently we have contracted with Irji Gold with very similar projects as we did for Altın Almaz, and moreover, we were actually committed with Irji Gold to implement ESG principles. And this is very important when industry look at the university's expertise in implementation of the ESG principles by themselves. Today's event is especially significant because it brings various stakeholders involved in the implementing of the ESG agenda. We will hear not only from our experts, but also company leaders such as our partners Altın Almaz and Russia experts from around the world. Altın Almaz is esteemed partner of our university. We are grateful for our long-term partnership and financed research projects. I thank all speakers and in Russia experts present today for sharing their knowledge and experience with us. A special gratitude to Ms. Claudia Kamker, the Environmental Affairs Officer of the United Nations Economic Commission for Europe, for supporting our event and joining us for this very important discussion. We appreciate your time and expertise. I wish everyone a fruitful discussion in the hope of bringing us closer to positive environmental change through nature-based solution projects in the region. Thank you for your attention.
Спасибо большое, Мирас Мухтарович, за выступление. А теперь позвольте передать слово доброму другу университета Нархоз, представителю Департамента глобальных коммуникаций ООН Республики Казахстан Властимилу Самику. Властимил?
Yes, thank you very much. Good afternoon, Your Excellency, Mr. President of the University, Mr. Provost, dear friend Brendan, all participants. First of all, thank you very much for this kind of exclusive opportunity to be part of your event today. I'm truly pleased and honored. It's always great to see a large number of specifically young people discussing the very pertinent issues of let's say the ways how we can actually better and more responsibly be looking for the nature-based solutions to, in this particular event, respect and topic to mine industry waste. And I like actually the sound of topic itself, from research to practice, because indeed it's very important to be more focused on science, on research, because this is the way how we can find solutions that would be adequate to the level of the development of the science in the 21st century, and how actually the corporate with not only social responsibility could be reflected and implemented later on in the ways how we actually treat and save the environment we are part of. So logically, mine industry is one of the very important components of the at the global scale, and of course also at the regional and national scales of the industrial development. However, and this is always the biggest challenge, there's a lot of environmental issues attached to this particular part. And sometimes we feel that when we talk about the sustainable development goals and sustainability as such, that these issues are not being perhaps enough known to the public. The innovation and innovative kind of processes which are inseparable parts of the development, and also they are very much, I would say, a very important tasks for the science and for the research. They are not being shared with the public, and if we put all these things together, we find out that we are half blind, and we should not be half deaf. So again, here I would really kind of very much highlight the important role of the university in Archos in this respect, actually combining the economic research that is focused on the environmental issues in the mining industry, when just again we address this specific topic. At the same moment, I'm really pleased that there's a number of participants of today's conference, because for me it's a reflection how seriously is this issue being taken. And this is something what is, I would say, a very important contribution to, first of all, the successful development and protection of the environment in Kazakhstan. But again, it is also a very important message to the global world that Kazakhstan is a very important player, not only in mining industry or extraction industry, but also in the research. And this is what I would like twice underline, because this is very important. And also I would like to thank to all of you that you are organizing this event actually just a day before we together are going to observe and celebrate the 2nd of March, which is actually the day of the accession of the Republic of Kazakhstan to the United Nations. So it's also a very symbolic, I would say, day for organizing such an important international conference. And in conclusion, allow me, colleagues, friends, partners, also to send a message of well wishes to all of us with the first day of spring, because the spring is always associated with I would say the nature again, kind of being revitalized. And if I may make some sort of symbolic connection, the revitalization of nature on the 1st March or in March or in spring itself is its own kind of ways, but also I would bit attach it to today's event and topic, that we as humanity and as the humankind, that's our responsibility to help the nature to the extent possible, as much as we can, to really kind of to be in a good shape, and to make sure that the livable, sustainable environment will be around in the decades and centuries to come. So if I may quote the former President of the United States, Barack Obama, yes, we can. With that, thank you very much. Once again, I wish you a very productive discussion. And once again, thank you very much for inviting me to speak this very, very important event. Thank you very much.
Thank you, Mr. Samek, for support. Уважаемые коллеги, теперь позвольте мне передать слово директору Института устойчивого развития Казахстана и, собственно говоря, ключевому персонажу реализации этого проекта Брэндону Дюпрейе. Он расскажет чуть больше про проект и про его результаты. Брэндон, вам слово.
Okay. Can you all hear me?
Yes.
Okay. So I'd like to present you a little bit about what our research institute does in relation to nature-based solutions. We started working in this field in 2019, and since then we've had a lot of development and a lot of work on in this sector, which I think will be interesting for participants to learn about. Is my screen blinking, my video?
We see your screen, not video.
Yeah, your video is a bit weird, but the screen sharing is fine.
Okay, let me just maybe, all right, so I'll just present and please ignore the kind of blurby looking face of mine on this. So my institute works on applied research for sustainable development. And basically what that means is there's been a global push for the past 15 or so years since the passage of the Sustainable Development Goals for academia to play more of a role in taking research and applying it to the field to solve real world problems in relation to the implementation of these Sustainable Development Goals. So traditional academia, for the most part, works on academic journal articles which are published and shared amongst peers. While important, it's very important to bridge the gap between taking this academic research and applying it in practice. And this has been mandated by the United Nations as well, and there's been a global push for that. And so my institute tries to be this bridge between research and practice. And in that context, we work on projects linked with nature-based solutions. And I'll explain to you the definition of nature-based solutions, which is to protect, manage, and restore natural ecosystems impacted by industrial and urban waste, simultaneously benefiting people and nature. And so what does that mean? Basically, economic development and urban development, as well as industrial development, can impact nature. But you can use nature to try to help balance the impact of urban economic development and industrial development. So an example of that is, let's say you want to make a new shopping center near a flood zone or close to a flood zone. It may not be necessarily a good idea, but you can help reduce the chances of your shopping center being impacted by floods that are happening more and more frequently due to climate change by looking scientifically at what types of plants and vegetation can be planted to help reduce the level of impact of flooding. Or if you're building a house on the side of a hill, in Almaty, it's surrounded by very steep mountains, and there's big issues linked with mudslides and with landslides. And so you can look scientifically at what types of plants and vegetation can be planted in order to reduce the probability of landslides or mudslides happening due to some economic development or urban development project that you might have in some hilly areas. So these are just a few examples of nature-based solutions to put it into context for you. And our work actually has been internationally recognized. So our work has been presented as a good practice within the scope of the United Nations Economic Commission for Europe, a convention on water and industrial accidents. They have a joint expert group meeting, which was in Budapest, Hungary in October. And our work was presented there as a good practice. As of recently, actually, only in the past few months, we have also been invited by the Republic of Kazakhstan to be part of the interinstitutional working group on mine safety. And so there will be a meeting March 15th, and I will attend, and our partners from Altinomas will also participate to talk about the good practice that we have conducted at Aksu mine. And moreover, my institute was recently appointed as a committee member for the National ESG Committee for Green Urban Development. And we're very proud of that and happy to be a part of this initiative and to share with some of our concrete examples of what can be done in this sector and to learn from our colleagues to try to develop ESG in greater detail in Kazakhstan and throughout the region. So now I would like to give you an example of one of the practical works that we've done in the field of nature-based solutions. And this concept is called phytocapture. And to better explain this concept to you, I will be sharing with you shortly a video that we prepared to discuss the concept and how we have applied it. One moment, please. Can you see the video?
Not yet.
One second. Just let me technically organize it here.
Yeah, but we hear a sound.
Okay, I think I just need to.
You can show it. You can turn off the demonstration and put it again.
Reshare again with the video. Now you can see it, right?
Right.
Okay, one second. Have you ever been to a construction site and seen dust flying around in the air? Have you ever wondered what is that cloud you see in urban cities during peak traffic hours? What you see is fine particulate matter called PM, which is tiny particles of organic chemicals, acids, metals, and dust emitted from fossil fuel burning vehicles and factories, construction and mine tailing sites. These particles can easily penetrate the human respiratory system, causing lung and cardiovascular diseases or exacerbating respiratory illnesses. By one estimate, 8.9 million deaths a year globally could be attributed to exposure to outdoor fine particulate matter. This problem exists not only in urban cities, but also in industrial sites like mine tailing sites. To tackle this pressing problem, the Sustainable Kazakhstan Research Institute has developed an innovative nature-based solution to deal with airborne dust and to help support the implementation of the Sustainable Development Goals through innovative nature-based solutions. The technical solution is called phytocapture. This approach uses various vegetation types, such as trees and shrubs, to disperse and also capture particulate matter on the surface of this vegetation. Using advanced computer modeling, our international experts model plant surface atmosphere interactions concerning the outdoor environment with various types of pollution such as PM. Using the model, we support industry and local governments to examine the best location, design, and plant combination of the vegetated barrier that can be used to reduce particulate pollution and scientifically illustrate the improvement of air quality that will occur with such designs. Our research team has proven such a barrier can reduce PM from source pollution by over 35% and other emissions by over 70%, providing a direct and positive impact on human health. The Sustainable Kazakhstan Research Institute can not only model these designs, but also has an international team of experienced experts that can help support the technical process of planting the barrier. Our research team is at the service of industry, city governments, and other stakeholders around the world to provide world-class services to those in need. The SKRI, providing technical solutions to some of the world's most pressing sustainability challenges. Okay, and now I would like to give you a few examples of how it can be applied in different contexts. So here is just kind of two examples that haven't actually been implemented, but to get an idea of the context. So there was recently an Ibis hotel which was built in the center of Almaty. And there they had planted several varieties of trees on the outside of the hotel. So what we can do is we can take a computer modeling and we can suggest for the company what types of trees to plant and where in order to better reduce dust pollution for the hotel guests who are going there and sleeping at the hotel. Other option is if they already have a design set up, we can model for them and to see how much dust and pollution is reduced based on the design that they have developed for their particular landscape design. And the same goes, for example, if there's some urban city development, such as the tree ring road around Astana. Actually, with that project, we could have done the same thing, which is to look at how they're planting the trees, what is the design, and to suggest to them better designs in order to reduce the impact of pollution to the city of Astana. So there's many practical applications to this, and we did this for the campus redevelopment project for Narhos University as well. As you know, we had a very large investment in redeveloping Narhos University campus. And what we did is we modeled Jandosova Street, which is the big street which is directly adjacent to Narhos University. And there we were able to calculate the number of cars, the types of cars, and the amount of pollution that was basically affecting the campus over the course of a 24-hour period. And based on that, we looked at what the landscape design was for the remodeling project. And we looked and determined what type of design would be most effective to reduce dust for the students and for the faculty at Narhos University. So on the right side, you can see what we did is we took all the pieces of vegetation which were either existing already or were to be planted at Narhos University. We modeled all of that in a computer simulation along with the traffic which was going down Jandosova Street. And we looked to see what the reduction of various types of pollution would be over the course of a 24-hour period. And here you can see, based on the computer modeling, we decided to do carbon monoxide and PM 2.5. Carbon monoxide is directly linked with, it's a gas, and it's linked with actually issues with being concentration with students, and also with levels of energy. Like if you inhale a lot of carbon monoxide, you become tired, groggy, and you're not able to concentrate more. And what we saw that based on the botanical garden and the landscape design that we had for Narhos University, that over the course of a 24-hour period, that carbon monoxide is reduced by 78%, and PM 2.5, which is basically particulate matter 2.5. These are very small pieces of dust. It was in the video, so hope you caught that. It's just basically dust that gets into your lungs and can cause respiratory problems. That was also reduced by 74% over the course of a 24-hour period, thereby, of course, improving the student environment and student experience at Narhos University. Now I'd like to give you an example of the application of phytocapture for industrial sector. So industry, basically, to give you a short description, is when you extract different types of metals like gold or silver or whatever it might be. Basically, you take ore from the ground and you break it up into small pieces. And for every 5 kilograms or so of rock, you get maybe 1 gram of gold. And so basically all of the rest that's not gold is a byproduct. And mining companies need to find something to do with that. And so what they usually do is they pile it up into big piles called tailings. And these tailings also tend to contain some toxic materials. Arsenic, for example, can be inside of it. And it's not good when this dust, this byproduct dust, is blowing around in the air. And so they usually try to find a way to suppress this dust. And they can do that with lots of different methods. One is a Bowser system, like you see on the picture below, the lower picture. It's like basically a truck, and then they spray chlorides next to the tailings to try to reduce the dust that's being blown around. And then the top one is basically, it's like a gun, kind of like a spray gun system, which is stationary, and they can spray it on the roads and like spray it next to the tailings. But the issue is because it's just a liquid with chlorides, it needs to be done regularly. So it's not just something that's done once and you forget about it. You have to do it either biannually or annually, and it's very expensive. Also, chlorides that are used can leach from the road surface and can be dangerous, or not dangerous, but not good for local vegetation growth. It can change soil chemistry and further hurt aquatic environments and also some of the vegetation surrounding the mines. The concept that we have is quite good because it helps companies comply with regulatory requirements in Kazakhstan as well. So there's the subsoil code of the Republic of Kazakhstan, and it requires all companies to give 1% of their total profit for research projects. And so phytocapture and the modeling that we do on the supercomputer can be covered under this research requirement that they have. Secondly, there's the environmental code of the Republic of Kazakhstan that calls for like best available international practices to be applied to the mines. So this helps them comply with the best of within the mine facilities. And so this project can be covered under the subsoil code as a research project, and secondly can be covered under the sanitary zone requirements because we plant various forms of vegetation on the mine facilities. And so we did this at Aksu mine. Aksu is an issue because near the mine facilities there's a village, and that village is impacted by mining operations. But I won't discuss this in detail because it will be covered by Bakram and Abroy from Altinomas in the next presentation. But we applied it at Aksu mine. And so basically what we do is we cover initial scoping. We do scientific modeling on a supercomputer to see the interaction with different types of pollutants coming from the tailings and different combinations of vegetation that can be planted in order to maximize the amount of dust capture. We do various reports for analysis that can be done, that can be distributed internally for the ecology departments. If they want to be planting vegetation, they can use these reports and plant vegetation on their own, and also for promotional purposes as well once the project is over. But finally, we do have a team of experts that can help with the whole process, ranging from doing the modeling to going on site and working with the companies and ensuring that the proper designs and implementation are done of the phytocapture barrier. And this is actually what we did in the case of Aksu mine. So the benefits of this is low cost. Unlike these spray solutions that I was talking about, like the Bowser system or the spray gun, it's a long-term solution once the trees grow to the appropriate height. So, a tree can last for, 30, 40, 50, 60 years, 100 years even. So it's quite a long-term solution. It aligns with national regulations, as we spoke about. It's environmentally more friendly than other solutions. It provides scientific evidence and methodology to site beautification projects. So basically, like I was saying, usually companies are planting vegetation anyway, but there's not really a specific methodology to do that or to model the impact of different designs or different number of pieces of vegetation that are being planted to see how to do it in the most effective way that's going to reduce dust in the most effective way. And this is why our project is unique, because we can provide the scientific evidence for that. And also it's very good for environment, social governance, ESG requirements, and consumer outreach. And just to give a couple very short slides on another line of work that we do, which is nature-based solutions to tailing water waste. This is with our partners from Tau Engineering firm, but they also have a foundation, Tau Foundation, and they have been a gracious donor to many of our mining projects. And they have a very good team of experts that we'll hear from later in this conference. And they do a whole host of very interesting work on nature-based solutions. And this is a current ongoing project that we have with them, where we did a literature review of best practices of water waste. We developed an inventory of facilities in Central Asia with transboundary impact. And now we're going to be doing 2 site visits to collect data and to develop a preliminary nature-based design for the specific sites that we visit. One of them is in Kyrgyzstan. We've already selected it. It's Aktuz mine, and we got approval from the shareholders to go there. And the second one will potentially will be in Kazakhstan, but the site has not been finalized yet. And the hope is that we will do the same thing, where we will actually apply this on site in order to actually bridge the gap between research and practice. And here you can see this is the, we've completed the literature review, and we developed a guidebook on that with different types of ways to solve water waste coming from tailing facilities of mines, whether it be covers like a dry cover, wet cover, how to increase pH levels, how to remove heavy melters through heavy metals through filter systems, and the issues linked with phytostabilization and phytoextraction, just to name a few of the things that we worked on. So as I mentioned, the next thing is to do a site visit to these 2 locations, one in Kazakhstan, one in Kyrgyzstan, and to develop a conceptual design that can then be implemented by funding partners, whoever it may be, whether it's a private company or whether it's a governmental agency that would like to see mitigation to water waste coming from abandoned tailing facility, or a bilateral fund coming from, for instance, the German government or the Finnish government. But that is a future line of work for us, is to actually get it financed once we develop the designs. And so the future work that SKRI will have in this is that we want to have further commercialization of our nature-based solutions. So we have our air project, which will be expanded. We want to work on water, and in the future, long run, we'd like to work on soil pollution coming from mining industry. And we'd like to explore some work with other partners, and of course, deepen our working relationship with our current partners, such as Altinomas. So thank you very much for your time. And if you have any questions, I will be here till the very end, so I can answer them at the end of the conference. So I'll give the floor back to Andre, and he can introduce our partners from Altinomas.
Спасибо большое, Брэндон. Да, позвольте передать сейчас слово другой стороне, нашим коллегам из Алтын-Алмаз. Сейчас перед вами выступит директор департамента охраны окружающей среды Абыро Бактыгали. Я так думаю, своими впечатлениями и результатами от этого проекта. Абыро, пожалуйста, вам слово.
Здравствуйте, уважаемые коллеги, уважаемые участники конференции. Разрешите мне продемонстрировать свой экран. Надеюсь, всем видно. Еще раз хочу поблагодарить всех участников данной конференции, поблагодарить Брэндона за приглашение на участие в данной конференции. Почему? Потому что с 2020 года мы совместно с Институтом устойчивого развития Нархоз ведем данную работу. Была проделана большая работа. И разрешите мне сегодня в рамках данной конференции рассказать, какую научно-исследовательскую работу мы провели на базе Алтын Алмаз, в частности на руднике Аксу. Как до этого Брэндон рассказал во время своего выступления, в 2020 году научно-исследовательский институт устойчивого развития Нархоз обратился в Алтын Алмаз с предложением провести научную работу с использованием специального программного обеспечения и установить так называемый фитозахватный барьер пыли. После чего была проделана большая работа по изучению материально-технической базы, была проведена работа по определению места, где будут высаживаться наши саженцы. И также были изучены все возможные доступные на тот момент документы для того, чтобы полностью изучить все компоненты окружающей среды того места, где мы планировали установить данный фитозахват. И для этого месторождение Аксу, на нашем языке будет называться рудник Аксу, был выбран не просто так. Почему? Потому что исторически так сложилось, что близлежащие населенные пункты, они образовались вокруг нашего рудника еще в прошлые века. То есть это бывшие поселения, будем так говорить, вахтовиков, которые жили возле рудника. В дальнейшем эти, будем так говорить, вахтовые поселки разрослись в полноценные поселки, где сейчас уже проживают люди, это получается их поколение, да, и таким образом получилось так, что наша производственная площадка, она находится в непосредственной близости с данными населенными пунктами. Поэтому и было принято решение, что попробовать использовать проект фитозахвата пыли на хвостохранилище нашего проекта Аксу-Кварцитовые горки с той целью, чтобы и провести научную работу, и с другой стороны, как Брэндон до этого в своем выступлении сказал, также и охватить социальную часть нашего вопроса. Поэтому, как я до этого еще сказал, что первым этапом работы были проведены научно-исследовательские работы, изучение материально-технической базы, документации. После этого мы определили, где мы будем высаживать наши саженцы, для того, чтобы обеспечить фитобарьер. Также провели обследование той местности, где мы запланировали будущую посадку. Как вы видите на своих экранах, с левой стороны картина показывает общее расположение нашего хвостохранилища. Как вы видите, вот он находится поселок. И здесь в правой картинке указан вот этот маленький участок, который находится в непосредственной близости с нашими населенными пунктами. И зеленым цветом указано то место, где у нас произошла посадка наших зеленых насаждений. Конечно, здесь могут быть у вас вопросы, почему посадка в основном произошла у нас на западной стороне хвостохранилища, тогда как поселок находится на восточной. Это все как раз таки обусловлено тем, что были изучены все необходимые документы, в частности, роза ветров, да, данной местности, где было выявлено, что в основном роза ветров дует с востока на запад. Поэтому и было принято решение, что с западной стороны будет посажена полная линия, и, конечно же, с восточной стороны данная часть также будет охвачена посадкой наших зеленых насаждений. Далее, как Брэндон уже говорил в своем выступлении предыдущем, полученная информация Институтом устойчивого развития Нархоз, информация была проработана на суперкомпьютере программным обеспечением NVMe, которая нам позволила понять, какие эндемичные виды растений мы можем использовать для посадки, какое расстояние от источника загрязнений и до саженцев должно быть, какое расстояние должно быть от саженцев и до населенного пункта. Было промоделировано также расстояние между этими растениями. Почему? Потому что мы в данной работе использовали 3 вида разных растений. Они отличаются друг от друга как своей спецификой, разновидностью, также и высотой. Поэтому на данном суперкомпьютере был смоделирован фитобарьер. И весной 2022 года был завершен второй этап проекта, то есть непосредственно сама посадка данных саженцев или установка фитобарьера на выбранных участках. Было высажено 1400 саженцев вяза, клена и лоха серебристого. На данных фотографиях вы можете увидеть, как это у нас все происходило и как это выглядело на тот момент, когда непосредственно произошла посадка. После чего силами нашей компании мы огородили каждый саженец вот такими вот дополнительными барьерами. Почему? Потому что, как вы, наверное, все хорошо знаете, что в таких населенных пунктах крупнорогатый скот любит расхаживать по полям, да, и, соответственно, питаться растительностью. И для того, чтобы защитить наши саженцы от крупного рогатого скота, ну и также от домашнего скота, мы сделали вот такого рода барьеры. Далее, третьим этапом работы это была проверка того, насколько наши саженцы прижились и что необходимо сделать дальше для того, чтобы обеспечить их максимальное приживание на данной местности. Поэтому осенью 2022 года вместе с членами Института устойчивого развития Нархоз была проведена еще очередная поездка на рудник Аксу, где мы проверили все вышеуказанные параметры и пришли к очень, скажем так, хорошему заключению. Приживаемость наших саженцев составила более 93% от общего количества высаженных растений. Наверное, те коллеги, которые уже, скажем так, принимали участие в такого вида работах, наверное, поймут, почему данный показатель является очень высоким и почему мы этому всему удивились. Потому что в среднем по Казахстану приживаемость, скажем так, саженцев после посадки составляет или же 50 на 50, или же 70 на 30. Поэтому показатель 93% это достаточно очень высокий и очень хороший показатель. Вот, кстати, вы можете увидеть на фотографии, как выглядят наши барьеры и как они, и как таким образом были защищены наши саженцы, да, от домашнего скота. С правой стороны вы можете видеть территорию хвостохранилища. Вот, и в целом на сегодняшний день таким образом выглядит наша высаженная полоса. Конечно же, мы все хорошо понимаем, что эффект от данного барьера он не будет сиюминутным. Для того, чтобы достичь хоть какого-либо эффекта от посаженных растений, естественно, необходимо нам подождать от 4 и более лет, когда уже данные саженцы окрепнут, окоренятся и, соответственно, вырастут в рост, для того, чтобы они могли сдерживать при ветрах частицы пыли, про которые рассказывал в своем выступлении Брэндон. И подводя итог данной работы, я хотел бы отметить, что в принципе озеленение проектов, оно не является чем-то новым для производственных компаний. Озеленением проектов занимаются, можно сказать, все недропользователи, которые работают как в Казахстане, так же и в других странах мира. Данные мероприятия, они входят также в так называемую программу природоохранных мероприятий, да, при получении экологических разрешений в уполномоченных государственных органов. Но в этот раз, получается, мы провели эту работу с применением компьютерного моделирования NVMET, с приложением, использовать которое к нам пришло от Института устойчивого развития университета Нархоз. И, в принципе, мы, конечно, очень рады полученным результатам. Почему? Потому что, получается, в этот раз посадка произошла не просто, скажем так, по интуитивному там соображению, да, то есть здесь была проделана действительно работа по изучению эрозии ветров, и здесь также использовались принципы ESG, да, то есть мы на сегодняшний день компания «Алтын-Алмаз», группа компании «Алтын-Алмаз» с прошлого года начала свое развитие по принципам ESG, поэтому для нас это слово, оно не чуждо. И рассматривая экологические вопросы, мы также, конечно, должны рассматривать и социальную часть вопросов, в соответствии чего, конечно же, мы должны максимально минимизировать наше негативное воздействие на окружающую среду и тем самым, естественно, учитывать требования и пожелания общественности, населенных пунктов, возле которых производится наша работа. Поэтому мы хотим поблагодарить Институт устойчивого развития университета Нархоз за проделанную работу. Теперь вот мы сейчас ведем работу по тому, чтобы получить окончательные виды документов, да, то есть методички, рекомендации, так как по итогам данной выполненной работы, естественно, мы хотели бы на руках у нас иметь специальные методички, рекомендации, которые могли бы быть нам полезны и в будущем, потому что мы не считаем, что данная работа будет у нас разовой. В будущем, конечно же, мы всегда будем иметь в голове, естественно, думать о возможности применения такого подхода к озеленению на всех других производственных объектах группы компании «Алтын-Алмаз». Вот, ну, я думаю, что с этим никаких проблем не будет. Я думаю, что университет Нархоз свою работу данную доведет до конца. Мы получим наши методички, изучим их все и, соответственно, уже в дальнейшем будем принимать решения. Поэтому еще раз хочу поблагодарить научно-исследовательский институт устойчивого развития университета Нархоз за проделанную работу. И я также теперь хотел бы передать дальше слово Брэндону для того, чтобы он продемонстрировал видеоролик, который был снят по итогам проведенной работы вместе с университетом. Если у вас есть вопросы, я готов ответить.
А можно сейчас такой задать?
Да.
I think we're saving it till the end of the. I think we're planning on saving
Okay.
questions to the end.
Okay. Then, Brendan, I'm handovering to you for
Yeah.
the short video
Could you just
material.
stop sharing your screens and then I'll share it. You just have to put stop share. Okay, I'll do it now. One sec.
Золотодобывающая компания «Алтын-Алмаз» впервые внедрила метод цифровых технологий по захвату пыли для рекультивации хвостохранилища на своем производственном объекте АКСУ кварцитовые горки в Архангельской области, где компания начала работать с 2019 года. Добыча золотосодержащей руды в Алтын-Алмаз ведется на 9 казахстанских месторождениях. Алтын-Алмаз входит в топ-3 крупнейших производителей золота в Казахстане, как по производству, так и по величине ресурсной базы. Компания занимает 3-е место по количеству золотоносных операционных месторождений и является лидером среди золотодобывающих компаний по количеству регионов присутствия. Придерживаясь принципов ESG, в Алтын-Алмаз внедряют передовые инновационные решения, которые могут снизить влияние производства на окружающую среду. Важный проект с точки зрения охраны окружающей среды и безопасности производства – решение проблемы запыленности на территориях хвостохранилищ. Один из проектов компании – это захват пыли на хвостохранилищах. Зеленые насаждения играют роль в управлении и поглощении переносимых по воздуху частиц, дабы предотвратить их попадание в окружающую среду. Для максимальной эффективности для посадки зеленых насаждений на месторождение Аксу кварцитовые горки использовали цифровые решения. Проект реализован совместно с ведущими учеными научно-исследовательского института по устойчивому развитию НАО «Университет Нархоз», которые к вопросу подошли с точки зрения науки и современных технологий.
Алтын-Алмаз is taking an important step towards sustainability by implementing this innovative project. Phytocapture takes the idea of going back to basics and using nature as a source to solve highly technical problems related to mining tailing waste. International organizations like the United Nations Environmental Program, as well as national legislation like the Kazakh Environmental Codex, all call for innovative nature-based solutions to mining tailing waste. This project is a very important step in that direction. We hope that our collaboration with Алтын-Алмаз in the field of ecology continues in the nearest future.
При помощи 3D-моделирования была определена территория посадки саженцев. Амфитовегетационный барьер разработан на основе программного обеспечения NVMAC, которое позволило создать 3D-модель зеленых насаждений и проанализировать эффективность фитозахвата пыли. Программа основана на теории вычислительной гидродинамики для разных видов растений. Для изучения рассеивания загрязнителей воздуха ученые использовали метод Эйлера, простейший численный метод решения систем обыкновенных дифференциальных управлений, который позволил изучить рассеивание аэрозольных частиц, а также пассивных или активных газов. 1400 саженцев деревьев и кустарников, такие как вяз, серебристый лох и клен, были высажены на расстоянии 1,5 километров. Эти виды растений были выбраны не зря. Серебристый лох, который имеет высоту около 1,5 метров, эффективен для удержания крупной пыли, а клен и вяз, благодаря росту более 3 метров и обилию листвы, помогают при удержании мелкогабаритной пыли, которая в ветре. Выбранные растения будут эффективны и в санитарном отношении, достаточно устойчивы к загрязнению воздуха и почвы промышленными выбросами. Компьютерное моделирование показало, что чем ближе деревья к источнику пыли, тем выше эффективность фитозахвата. Именно поэтому расстояние между хвостохранилищем и посадкой 10 метров. А расстояние между деревьями и кустарниками варьируется от 1 до 2,5 метров. Таким образом, загрязнение воздуха будет снижено до 40%.
Рождение Аксу основалось с 1939 года, начало столетия. И вскоре вокруг него образовался поселок старателей, поселок Аксу. Формирование хвостохранилища, тесно связанное с производственным процессом по добыче и переработке руды, начато в 1951 году и по настоящее время производит путем подачи через пульпопровод пульпы в проводно-извлекательные фабрики Азии.
Следующие меры при прекращении негативного воздействия хвостохранилища, как расширение технологических дорог хвостохранилища, а также соблюдение надводного запаса СТРТ, не полным решением данной проблемы. Университет Нархоз в 2020 году был представлен проект способный заезжим загрязнителям. Данная гипотеза и послужила обоснованием данного проекта. В мае 2022 года были проведены работы по установке барьера.
Проект по фитозахвату пыли внедрен компанией «Алтыналмаз» на западной и восточной стороне хвостохранилища рудника Аксу в Акмолинской области. Этот подход планируется внедрить на других производственных объектах, а максимальный пик эффективности фитобарьеров будет достигнут через несколько лет, когда растения укоренятся и вырастут, и тем самым создадут собственный микроклимат, удерживая потоки пыли.
Мы смогли моделировать весь этот процесс и конкретно понять, на каком расстоянии должны находиться эти пояса от источника загрязнения, на какой дистанции должны находиться близлежащие населенные пункты от данного зеленого пояса, какое расстояние должно быть между растениями и какие виды и типы растений мы должны использовать. Наш проект в Акмолинской области исторически сложилось таким образом, что многие насекомые находятся вблизи наших объектов. Поэтому такие работы, как установка фитозахватных барьеров, озеленение и использование технологий таких природоохранных мероприятий является очень важным моментом и очень важным фактором в вопросах охраны окружающей среды, также социальной минимизации влияния производственных факторов на флору, фауну и ближайшие населенные пункты.
Забота об окружающей среде – это не просто конкретные обязательства. Для компании это концепция ежедневной деятельности. Только за 2021 год на реализацию природоохранных мероприятий компании направлено $1 800 000 США. Придерживаясь принципов и стандартов ESG, компания «Алтыналмаз» объявила 2022 год годом экологии. Проект фитозахвата – пример реализации политики охраны окружающей среды для лучшего и безопасного будущего. Будущего в гармонии с природой.
Так, Брэндон, Аброй, это все у вас, да? По выступлению?
Yes, да,
Okay.
да.
Спасибо большое за такой увлекательный доклад, было очень интересно. И теперь я хотел бы передать слово нашему коллеге из университета Нархоз Хамеду Шерифи, эксперту по моделированию качества воздуха. Я так думаю, что Хамед сейчас с нами поделится информацией о том, как конкретно все это подсчитывалось. Очень интересно узнать чуть больше о прикладных моментах. Хамед, are you here? Yes, you're here.
Hello, everyone. So, my name is Hamed. I'm an associated professor in SKI team at Northwest University. This presentation will explain dust emission modeling over tailing facility of Aksu mine. To see the big picture of the modeling, we should firstly see the problem. About 8 kilograms per hour dust emitted from tailing facility in Aksu mine, and it caused a lot of health problems in residential area. So, to solve this problem, in line with the policy of the company and based on the literature review, phytocapture barrier can be used as an important tool for the protection of ecological and human health. This concept could prove to be a useful tool for mitigating the environmental impact from the mining industry. Before take any further action, and to prove effectiveness of this concept, we should have firstly used simulation to design. After a lot of reviews, the SKRI team concluded that to use one of the state-of-the-art software called EnviMet. This software used for a wide range of applications, including urban planning, building design, and energy efficiency, considering not only one single climate parameter, but all of them. It is a multifunctional software that worldwide used by university and international companies. It can be used to assess the potential of new buildings, green spaces, and urban planning, and to make informed decisions to mitigate the effects of climate change and ensure a more sustainable future for everyone. For example, in terms of less polluted areas, it can be used to locate new establishments, also used to model safe zone places. So, to use this software for Aksu mine case, our simulation divides into two parts, east and west side of the tailing facility. For the east side, we simulate total emission rate with 1.5 kilometers vegetation barrier, and for the east-west side, we simulate about 4% of the emission rate and 180-meter vegetation barrier. 8 scenarios were investigated with high-speed computer to find the best design and the best type of trees. We used available local trees in these scenarios. The simulation comes up with an effectiveness up to 40% in both parts, east and west. The graph shows an effective component of dust capture. The density of the dust is high enough to be trapped in lower parts or near the ground. Dust blows horizontally and down the base of the tailing. As you can see, the left pictures are 3D and 2D simulation of the west part, and the right picture is a 2D simulation of the east part. As you can see, these real-time simulations show the effectiveness of using vegetation barriers. So thank you all. If you have any questions, feel free to ask.
Thank you. Thank you, Mr. Sharifi. And now, please let me give the floor to our colleagues from Town Engineering Firm. Да, теперь хотел передать слово нашим коллегам из фирмы Town Engineering. Это наши коллеги, с которыми Институт устойчивого развития Казахстана давно работает по некоторым нашим проектам. Мистер Гвидо ван де Котерле. Вы здесь?
Yes, good afternoon. Can you hear me?
So please, the floor is yours.
Thank you. I'm doing the presentation together with my colleague Ellen Verboom, who's also in the meeting. Ellen, can you share your screen?
Yes. Wait, share screen. Do you see the total presentation or the overview of slides?
The overview slides with the notes next to it. Okay, so you have to switch screens.
Share screen, and then this one. Does it work now?
We're not sharing at the moment. That's your mailbox. Yeah, that's it.
Yeah, okay, cool.
Thank you. Yes, welcome, good afternoon. This is a presentation by TAO on nature-based solutions for mine tailings. It's by myself and my colleague, Ellen Verboom. Maybe next slide, Ellen. We'll briefly give the presenters and the organizations, and then we'll give some examples of nature-based solutions that have been implemented by TAO, and we will reflect on possibilities in Central Asia. Next slide. So, my name is Guido van der Gollet. I'm a project manager of international environmental projects at TAO. graduated from the University of Amsterdam in the UK. I have 17 years experience with the investigation development of conceptual site models, risk assessment, and contaminated sites. I've been working, amongst others, in Kyrgyzstan, Tajikistan, Georgia, Armenia. Basically, I work everywhere. And Ellen Verboom, my colleague, she has joined us. She has a background in natural sciences and biology, so she's more on the biological side. I'm more on the contamination side. So next slide, please. A little bit about TAO. We are a European environmental engineering and consulting company. Established in 1928, so nearly 100 years old now. We originally started as the Technical Advisory Bureau of the Union of Watershed Boards, essentially meaning designing pumping stations, water treatment systems. We have been a leading company in contaminated sites since the 1980s, so we have over 40 years experience with this, and we have done some of the most polluted areas in Western Europe. And we are employee owned, so we are not on the stock exchange. Next slide, please. So nature-based solutions at TAO. What I mentioned before is that we have decades of experience in different types of contaminated land cleanup, and that's both in situ, which essentially is to try to biodegrade or degrade the contamination without leaving the site, or ex situ, which is what we call dig and dump. But we have been developing nature-based solutions over the past 10 to 20 years, and in addition to traditional nature-based solutions like phytoremediation, we have also more innovative nature-based solutions. And what you see here on the picture on the top right, it's a chemical waste dump of 100 hectares. So this place is full of dioxins, full of oil, pesticides, everything, and it was 100 hectares in size. And what we developed on this chemical waste dump was a peatland. So essentially it was a very wet area, and we constructed a top cover encapsulating the contaminated waste. And this top cover basically regenerates itself, it keeps itself going, and it has been developed into a very nice nature area. And it's called the Volgemeer dump site. It was one of the biggest, if not the biggest, remediation project in the Netherlands, worth about 100 million euros. Next slide. Now my colleague Ellen Verboom, she will take over and she will present some practical examples that we have implemented nature-based solutions.
Yes. So as Guido just mentioned, we have a lot of experience at TAO with site remediation, also with the use of nature-based solutions. And we are currently working on a project that's looking into remediation of mine tailing impacts through nature-based solutions. Brendan already told you a little bit about this during his presentation. We're specifically looking at the pollution from mine tailings through leachate. So water that flows out of these tailings and contains harmful pollutants. We focus on acid mine drainage and heavy metals for the most part of the project. And for this project, we also looked at older designs of nature-based solutions by TAO to see if we could also implement those for this new project. So I would just like to present some of them to you, explain how they work, and after that, Guido will take over again and explain how these would be suitable for mine tailings specifically. So the first nature-based solutions I would like to discuss is a reactive mat that we designed for bioabsorption of pollution. This project focused on a polluted canal near Ghent, which is in Belgium. And this canal flowed past an old asphalt factory. So it was heavily polluted with aliphatic and aromatic hydrocarbons. And we designed a reactive mat in this canal. You can see here in the picture with a first section that contained biochar and the second section that contained peat. Biochar and peat are both organic compounds, so they provide a lot of binding sites that pollutants can bind to, and herewith they are filtered from the water. For this design, we chose biochar and peat because biochar is very effective filtering. It has a lot of binding sites, but it's also quite expensive, so that's why we implemented the combination between biochar and peat, because peat also is quite binding, but it's a bit more cheap. This was a very effective project. There was a reduction of pollutants from 85 to 100%, so that's very successful. And of course, for such a reactive mat, at some point, all the binding sites become saturated, so it would have to be replaced. And in this specific case, the replacement would have to occur every 10 years. And we're currently looking into options to recycle the reactive mats as well, so to try to desorb the pollutions and just place the old mats back again, so they can filter even more pollutants. I have some pictures of what it looks like in real life. So here on the left, you can see the inside of the mat. So it contains, it's made up of different compartments that are filled up, in this case of biochar, and they are simply placed in the stream. The water flows over it, and hereby the pollutants are filtered out of the water. Then a second nature-based solution is an iron oxide-coated sand filter that we designed. This was for a polluted lake, the Spiegelglas, which is located in the Netherlands. And there was a lot of pollution with phosphorus from agricultural soils, which is a very common problem in the Netherlands because we have very intensive agriculture, so a lot of application of fertilizers that a large part of them end up flowing out of the soil. Here on the right, you see a picture of the overview of the area. So here on the right, the dark part is the lake, and here in the middle were agricultural soils. And you can see little streams in between the field through which phosphorus-rich water flowed into the lake. So what we did is we constructed a filter here with this iron oxide coated sand. Iron oxide coated sand is a waste material from the devaluation of drinking water, which is usually just dumped at a dump site. So this is actually a very nice solution in two aspects, because it both cleans the pollution, but it also has a circular aspect to the nature-based solution. The phosphorus can bind to the iron oxide coated sand filter and is thus filtered out of the polluted water. And again, this was a very successful project. The filter removed 93% of the phosphorus load, so that's a very big reduction. And then I have a schematic overview of the filter. There's two possible flow directions for the water. The first one would be upflow, so there's a pump on the beginning of the filter that pumps the water into a basin, and then the pump pushes it upwards through an absorption filter with the iron oxide coated sand, and then it flows out again. The other option would be to let gravity do most of the work, so you would let the water flow in from the top and then have a downflow, so it just sinks through the filter basically and exits the filter again. The upside of the downflow is that it requires almost no energy because gravity does all the work. The downside is that the filter can get clogged because any suspended material that is present in the water will accumulate on top of the filter. Whereas if you use the upflow method, it will just lay on the bottom of the basin. So the downflow does require a bit more maintenance and upkeeping. So depending on the situation, a choice needs to be made there. And then a final nature-based solution I would like to discuss are the use of tree wells. Tree wells use trees to make a geohydrological barrier for contaminants. We did a project for Dow Benelux. Dow is a large chemical company. Here on the right, you can see the site location. So it's a very big industrial site, and we focused specifically on this area here, where there was a big problem with groundwater contamination with BTEX and chlorinated hydrocarbons. And we used tree wells to tackle this problem. I will explain in detail how this works exactly in the next slide. But basically, you plant trees and they provide a geohydrological barrier for the pollutants, so they cannot flow out of the already contaminated area, so the pollution won't spread. And to some extent, they also provide phytostabilization and phytoextraction of pollutants. So phytostabilization refers to immobilization of pollutants through adsorption. So the root system of the trees provide a lot of binding sites to which these pollutants can adsorb. But the trees also exude root exudates that change the microclimate around the roots, so that the soil itself also provides more binding sites for these pollutants. And phytoextraction is basically the trees just taking up the pollutants from the soil and allocating them to their above ground biomass, here with removing them from the soil. In this specific case, we used poplars for the tree wells, but eucalyptus or willow trees could also be used, basically any tree that grows fast and that has a high tolerance against pollutants. Now, for the explanation of how this actually works, here on the left, we have a schematic overview. So you have the tree, and you plant the tree, but you plant the roots in root containment, root sleeve, that is impermeable. So any water that is here in the soil cannot enter the root system. But of course, the tree requires water. So you place a tube with two filters, one in the root containment and one at the depth of the groundwater pollution. So as the tree evaporates water, the soil within the root sleeve dries up. And through this tube and filter system, the lower lying groundwater is sucked into this root sleeve. So what happens, say you have a polluted area here on the right, and your groundwater flows from right to left. When it gets to this tree, it gets sucked in, so it can migrate past this tree line. And for our project with the Dow site, we saw that it really, really worked. The pollution stayed contained within this tree well system. And here on the right picture, this is what it looks like when it's implemented, just a few rows of poplar trees that act as a barrier for this pollution. And then I will give the floor back to Guido, who will explain a bit more how these specific examples could be implemented in the case of mine tailing leaches.
Thank you, Ellen. Yes, of course. The examples we showed you were from the Netherlands and Belgium, which are two fairly low-lying countries which are have abundant water. However, the systems that we have presented can typically be transferred to other countries in other situations. From my personal experience, nature-based solutions work best when you have a lot of space, which Central Asia has, and they work also good when you have a lot of time. What we see in the Netherlands and Belgium, there's a lot more pressure on the land to redevelop it, to give it a new function, and that is one of the big hindrances for nature-based solutions, because they really need time and space. How I look at it from the Central Asian perspective is that the reactive mat can be efficient in treatment of acid mine drainage. Both biochar and peat are effective absorbents for heavy metals due to their negatively charged surface, and biochar can neutralize acidity, treating AMD. So it can be a good solution. You need to treat, of course, a water flow which cannot be too big, but also not too little. You need to find sites that are, really suitable for this setup. When we look at the iron oxide coated sand filter, it's good in removal of heavy metals through fixation. A copper, cadmium, a lead, nickel, chrome, and zinc. It can be used even for industrial wastewater and stormwater runoff. The tree wells are especially good when it comes to groundwater. So if you have groundwater contamination coming, tree wells can act both as a buffer, a barrier, as well as a method to really clean the materials. Now, in groundwater, the main issues tend to be rather from an oil perspective, as to say. Heavy metals in groundwater don't tend to travel very fast and very far beyond their source areas. So for groundwater, you would be looking at not so much heavy metals, but rather either oils or macro pollutants that would be that can be treated with this system. All in all, I do think there is a lot of opportunity in Central Asia to use nature-based solutions, and I think Narsot University is already on top of that, and they're really sticking their neck out and see how these new technologies and methods can be best implemented in Central Asia. Ellen, next slide. I think that's the last one. So there is. I don't know if there's time for questions, or you prefer to do that at the end of the meeting.
Yeah, we have one more presentation from Dora, and then we can have questions and answers.
Okay, good.
Very good presentation. Thank you.
Thank you. Теперь позвольте дать слово нашему последнему спикеру, завершающему, Дора Алмаси, руководитель исследований, проект «Атлас городской природы», часть проекта Британской академии «Представление карт природных решений». Dora, you're here? Yes, you're here. So please, you can start.
Thank you very much. I will start sharing my screen. Okay, can you see it well?
Yes.
Okay, super. So good afternoon, everyone. It's really a pleasure to be here. The presentations were very interesting, and I really enjoyed participating, so thank you for the invitation. A few words about myself. I'm a policy researcher. I'm working on topics in the intersection of environmental governance and assessment. And I have a PhD from the Central European University in Environmental Science and Policy. And for 15 years, I have been working on different international projects focusing on technical aspects and capacity building, mainly in the topics of climate change and nature-based solutions. Today, I want to talk about the project which I have been working on and coordinating for the last 5 years, the Urban Nature Atlas. This is basically a large-scale mapping exercise of urban nature-based solutions in Europe, but also anywhere else in the world. So originally, Originally, the Urban Nature Atlas was developed during a EU-funded Horizon 2020 project back in 2017 and 18 by the Central European University. It was intended to be the most comprehensive database of urban nature-based solutions in Europe. We produced it as a result of a systematic survey based on secondary resources such as project reports, articles, websites, and other documentation. And then we processed the data with the help of a research methodology called discourse analysis. And we presented all this data online in the format of an online platform that everybody can visit, and it's publicly available for everyone. When the project finished, the Naturevation project, which was a 4-year research project, finished, we started to work with the British Academy to extend this European map into a global map. Our aim was to look for cases that are jointly supporting both climate change and biodiversity protection objectives. And most recently, we started a project with the Asia Europe Foundation, which is an organization based in Singapore, facilitating exchange between European and Asian organizations. So we started the project with them, focusing specifically on nature-based solutions in Asian countries. The database includes various information, mostly on the implementation and the governance aspects of these projects. And these include goals, implementation activities, governance features, financing, the type of innovation that they deliver, and the benefits. So here, if you visit www.una.city, you will find the Atlas online. There is a map where and there is a filtering section where you can start looking for cases. I will show examples later, but basically you can choose cases based on various filters, what type of challenges they aim to address, what is the basic ecosystem that they are focusing on, what is the ecological domain that they are focusing on, and who is the implementing body, and so on. And once you find a project, you can read details about it. We have different sections and information. We collected both text-based data and also multiple selection questions, so you could have a more structured understanding of what the project is about. I will be giving examples, but I also want to provide you with some more high-level findings and what we understood about nature-based solutions in general. So first of all, we know that urban NBS can address multiple challenges. This means that usually we prefer to say that nature-based solutions have this capacity to deliver co-benefits. So even though we create a project for addressing a flooding issue, we can expect that this project will also contribute to other challenges, such as the regeneration of land or health and well-being of the citizens in the surrounding, or the preservation of a cultural heritage in the area. There is one example. This is the Library of Trees, for example, which is in Milan, in Italy. Their main objective was to create a park that is helping with the urban heat problem and also with habitat and biodiversity restoration and conservation. It's called Library of Trees because they created it in a way that there are different sections with different type of biodiversity. Here it's an early phase implementation. The trees hasn't really grown yet. But they, besides these environmental objectives, they also had various different objectives to preserve the natural heritage in the area, to preserve historic traditions, to promote social interactions, environmental education, and social cohesions. So there were several other side objectives. Another example is from Argentina. This is an urban gardening or farming project. Basically, they identified vacant, smaller areas in the city, and they started their urban gardening projects. And this has become so successful that it didn't only help with supporting low-income residents with food and access to livelihood, but it also helped with mitigating urban heat, flood management, stormwater management, soil quality improvement, and so on. So we can see that there is this capacity or this potential in nature-based solutions that they can bring multiple benefits at the same time. So after this short introduction, when we talk about nature-based solution in the Urban Nature Atlas, we are talking about a wide variety of different concepts: green infrastructure, blue infrastructure, ecosystem-based adaptation, nature-based adaptation. But one thing is common: these are deliberate interventions that are inspired or supported by nature, and they do have this additional benefits that they are cost-effective, and as I mentioned, simultaneously providing more than one type of benefits. We also know from the Atlas and from our big data collection that the urban nature-based solutions can take various forms, from green walls to parks, community gardens, rain gardens that can help managing water, constructed wetlands that can help with wastewater treatment, or even green indoor areas. And ideally, in an ideal world, we would like to see that these nature-based solutions are not like point examples and good practice cases in a city, but that they take a systematic approach and they help with these benefits in a systematic way, because the parks and the lakes and the river management solutions are appearing together. So, for example, just really a few examples. This is a green roof in Munich. You can see that we can consider this as a more innovative type of solution. In many German cities, we see that green roof installations are happening quite systematically these days, recognizing their various benefits. But not only very innovative solutions can be considered as nature-based solutions. Community gardens, allotment gardens, which allow citizens to come together and grow their own food within the boundaries of the city, just in their neighborhood, can provide a different type of experience for citizens. This is another example I want to show. It's not necessarily something new needs to be created to talk about a nature-based solution, but also existing nature areas could be used in a way to better manage flooding, for example. This is an example where the city introduced upstream flood management practices so that the city is not being flooded so frequently. And this is another one. This is in Sweden. They created smaller rain gardens next to the residential areas to make sure that when sudden rain is coming, this will not flood the neighborhood, and there is a place which can easily absorb the rain. So another finding or another message that I would like to give is that urban nature-based solutions can be implemented in multiple ways. Most frequently, we are talking about creating new green areas, which many cities are desperately needed. But sometimes it's not only about the creation. Sometimes it's only about the maintenance and the management of existing urban nature. How can we manage better what the cities already have? If there is a park, is there a way to make it more useful for citizens, to make it a place for physical activities, social interactions, preservation of cultural heritage? Can we use the existing spaces better? And then from this, the surrounding areas, the peri-urban areas in the cities, can we manage our rivers in environmentally friendly or ecologically suitable ways? And similar with the coastal areas or the ecologically degraded ecosystems. And of course, another potential application is when we don't necessarily talk about physical interventions, but softer measures like knowledge creation, awareness raising, developing a strategy, a plan or a policy. For example, in Hamburg, they established a green roof strategy that is expecting all new buildings to have a green roof on them. Improve governance of green and blue areas. If a city decides to not cut the grass in the public areas that regularly, and let the grass grow in a more natural way and create these wildflower meadows, this can help with biodiversity. It can cut costs. There are various basically low-hanging fruits that cities can implement in this way. Some examples, again, for this type of interventions. Obviously, this is the Bosco Verticale, again in Milano. This is an apartment building that was created as a vertical forest. Obviously, this is the type of intervention that requires more investment and a more innovative approach. But then, this is another one. This is from Budapest, my home country and hometown. Basically, this was an old unused square that the city district decided to turn into a very lively place where people can hang out and meet with each other. In addition, it's providing different environmental benefits. It has rain gardens to absorb the storm water better. This is another example. This is a very small-scale initiative. It's a rain garden implemented in the parking lot of a shopping mall. It's important to see that while the impacts and the benefits of such small-scale solutions may not be considerably big, but if this becomes a norm in a city and they have this implemented everywhere, it can really replace a major part of the grey infrastructure that is needed to take away the water coming from the rain. And then after a very small-scale initiative, this is a very large-scale one in Germany, where they basically did a renaturalization project to recreate the original state of the river Isar. And this provided various benefits from better flood management, biodiversity restoration, to opportunities for physical interaction, health improvements, and social interactions. This is a project where it's also in Germany, which is a greyfield development. So this was a degraded area, and they decided to renovate it and create a large new district with nature-based solutions and nature approaches in mind. And one last one. This is another project. This is in Oslo, in Norway, where they decided to open up the river. The river was covered previously. So they reopened an existing river, they restored the river area, and they provided, again, opportunities for the neighborhood for better air quality because of the trees, better recreational opportunities, and so on. And again, this is not necessarily nature-based solutions, not necessarily new intervention. This is a restoration project in Greece of an existing wetland area, mostly focusing on biodiversity benefits, but as the city Athens is close by, it has obviously different social and environmental benefits also for the citizens who live in the area. So what we know from the Urban Nature Atlas is that cities already are working with nature to address a wide range of urban sustainability goals. Obviously, most of the projects are supporting green space creation, habitat creation, biodiversity protection. But we see when we look at this large number of projects is that many of the projects are targeting health and well-being, the regeneration of their cities in a more naturalistic way, and social justice and social cohesion. Water management, environmental quality, and climate adaptation are also objectives and challenges that nature-based solutions can regularly address. The evidence from the Urban Nature Atlas also shows that urban NBS can have various benefits. In the brackets, you can see the number of the cases where we were able to detect certain impacts. Nature-based solutions in cities have extremely good capacity to help protection against flooding, to help with stormwater management, to lower local temperature, to increase the number of species present, to reduce loss of biodiversity. when we think about nature-based solutions, these can bring back original nature to cities. They have this potential to little bit lessen the borders between nature and city. And if we now go to, for example, many cities in Germany and Netherlands, Sweden, they really started to take this approach that they are integrating blue, green, and gray, and everything comes together. We also see that, as I mentioned, that they have really good potential to help physical health, mental health. Recent research has been really focusing now that the mental health benefits of nature-based solutions are really major. And they, of course, offer various opportunities for social interaction, access to food, improving livability, providing opportunities for marginalized groups. Many projects are helping to integrate people who are like the elderly, senior citizens, disabled people, and so on. So we saw that the examples are confirming existing research that nature-based solutions have this potential to deliver multiple benefits. And lastly, just a few takeaways is that obviously nature-based solutions are high-performance infrastructures, but they should be systematic and integral part of grey infrastructure to deliver these benefits. They have the potential to link together priority policy sectors. The smart city concept, climate change adaptation, public health could be all benefiting if these solutions are applied systematically. But it's important to see that they should be assessed and interpreted with an economic logic. They cannot compete with grey infrastructure solutions unless we don't take a market-based approach towards their application. And lastly, what is important is that this is still an early phase. The research has been really wonderful in the last few years. We have learned a lot about nature-based solutions, but implementation is still in an early phase. So it can only be happening if we accept that it is a trial and error process. And when planning, implementation, and even maintenance is happening, we see that many projects are having challenges, but this doesn't necessarily mean that the project is not good. It just means that certain things needs to be adapted before it can be upscaled. So this is all, and I will be happy to answer questions. Thank you.
Thank you, Dora. Уважаемые коллеги, выступления закончены. Сейчас у нас есть примерно 15 минут на сессию вопросов и ответов. Вы можете писать вопросы в чат для наших спикеров, и я их зачитаю. На данный момент у нас поступил вопрос, вы можете видеть его в чате, от Екатерины Калугиной, коллеги из Международного отдела университета Нархоз. Я так понимаю, это вопрос к Абырою Бактыгали, директору департамента охраны окружающей среды Алтын-Алмаз. Абырой, вы с нами, да? Вопрос звучит следующим образом. Почему не был высажен тополь? На самом деле тут серия вопросов, но все очень близко об одном. Почему не был высажен тополь? Кто выступал экспертами по отбору и высадке деревьев? Какая почва место высадки? Почему было не пересадить более взрослые деревья? Я думаю, это самый такой очевидный вопрос. Почему высажен только один ряд и на какую высоту поднимается пыль? Аброй, по возможности, вот на все эти вопросы кратенько.
Да, на самом деле, а как зовут
Екатерина.
Екатерина, да? Да, я думаю, что Екатерина как раз-таки поставила те вопросы, которые необходимо задать Брэндону, наверное, прежде всего. Потому что, как мы до этого говорили, Екатерина, как раз-таки работа по подбору и вообще по научному подходу, да, она вот делалась именно Институтом устойчивого развития Нархоза. То есть с нашей стороны мы, грубо говоря, предоставили поле для работы, и, соответственно, после этого уже по итогам компьютерного моделирования был подобран как раз-таки вяз, серебристый лох. Про тополь здесь разговора не было, поэтому здесь мы, наверное, может быть, Брэндон меня дополнит, почему не был высажен тополь, почему были выбраны именно те растения. Но, как я до этого сказал, мы вот эту информацию получили от Института устойчивого развития Нархоз, И как раз таки рекомендация была именно по этим 3 деревьям. Тополя не было. Кто выступал экспертом по подбору высадки деревьев? Институт устойчивого развития университета Нархоз выступал. Какая почва вместо высадки? Почва достаточно хорошая, питательный гумусный слой достаточно хороший, чернозема очень много, потому что мы говорим про Акмолинскую область. Вы знаете, там в Акмолинской области у нас очень хорошую почву по сравнению со средней полосой Казахстана, южными регионами. Так, почему было не пересадить более взрослые деревья? Здесь мы пришли к общему консенсусу, что те деревья, которые были выбраны, они больше подойдут по нескольким причинам. Основной причиной это, конечно, был бюджет. То есть в бюджете были заложены определенные средства, и если исходить от количества растений, которые мы выбрали, и, соответственно, были выбраны те растения, которые мы посадили. Так, почему только 1 ряд высажен? На самом деле не 1 ряд высажен, высажено было 3 ряда. На фотографии, которую мы вам показали, это было то фото, где была завершена установка вот этих вот наших барьеров от домашнего скота только на 1 линию. А так у нас их 3 линии.
Спасибо большое.
Okay, so I can summarize a little bit for that, and there's a reason behind that. So why did we pick those trees? There's 2 reasons. One of them is first you model, and you can model all sorts of different types of vegetation that could be planted there because the modeling software allows you to. But there's a big difference between theoretical application, what the software can model, and then actually going there and implementing something that's going to last and grow on site. And so this is a balance. When you do applied research, you have to have a balance between theoretical application and practical application. So when we originally did the modeling, we modeled some vegetation that looked like would be effective to capture dust at Aksumai. Then when we went there, we looked and we saw what actually grew on site. So we did soil sampling to see what types of soils were there and what type of vegetation could be planted. That was number 1. And number 2, we took photos and looked at what vegetation is actually growing there. So for instance, we saw that there was clone tree. They had clones which were growing there, the maple trees. And then we saw that there was also loch. This is an olive tree, that olive trees could grow there. And so we looked and we took a collection of what vegetation was actually growing on that site because it's a good indicator of what can survive these soils because the soils also have some contaminants inside of it. And then we modeled the different types of vegetation that we saw on site and matched it with the modeling. And then we looked at which combination of trees would be the best to be planted on site. And that's why we had those 3 rows, and that's why we had the 3 different types of trees that were planted there, because those are the ones that were most effective in capturing dust, number 1, and second, that would actually grow there. And the other issue is that you can't just have tall trees, because first off, if you work with tree planting companies, it's not realistic to bring and to plant 1,000 5 or 6 meter high trees. When you purchase trees from a company, forestry service, typically these trees are either 0.5 to 1.5 meters high or 1.5 to 2.5 meters high. And so basically what you purchase is based on what the availability is in the budget and what you can afford and what is practical between the 0.5 and 2.5 meters in size. And I would say the final thing in relation to that is the fact that, as Hamed rightfully pointed out, is that dust blows in 2 directions. One direction is horizontally from the top of the tailing. The other one is that the dust rolls down the bottom of the tailing. So you don't only need high trees, so like trees that reach the top of the tailing in order to capture the dust in the leaves, but you also need low-lying shrubs and grass, smaller vegetation, because this vegetation captures the dust that rolls from the top of the tailing down to the bottom and doesn't fly horizontally over the top. And so those are the reasons why, and I hope that's a good answer to your question.
Thank you, Brandon. Еще появились вопросы в чате от Олены Бондаренко, эксперта по ESG. Он на английском, я зачитаю. A question to all speakers. Last speaker mentioned in the social impact of nature-based solutions. In your experience, how important are these social governance components to ESG globally? Do you see companies worldwide and locally engaging in this work more? So, to all speakers, please, if you're ready, you can answer this question.
I can go first.
Please.
Go ahead, Dora.
Yeah, so I think especially with the last COP15 in Montreal, which was focusing on the CBD COP15 in Montreal, many companies recognize that this is a field where they should be working. So I think this is increasingly, we can see many more practices popping up. Companies either applying these nature-based solutions around their operational areas, but as part of their CSR activities, going outside of their usual operational areas and helping to restore or renovate a park in the city center of Bangkok, for example. I just saw there is a very inspiring project now in our database from Bangkok. A tobacco company decided to recreate or restore a natural forest area, very typical for that region. Many countries are, this shouldn't be, nature-based solutions shouldn't be about just offsetting the impacts. It should go beyond that. And I think the social engagement and the social interactions and the health improvements could be one way to do this very nicely. So I think nature-based solutions cannot be implemented without companies, and more example is visible for that.
Yeah, and I would also add to that one additional thing is the social component. So if you look at, like, for instance, the project that Altina Almas and our institute implemented, is that you have two aspects. One of them is site beautification, greening some area by planting trees, which is good for the environmental component. But then secondly, you have an issue where you have dust, which might not be so beneficial to the local population, which is, could potentially cause some issues, some problems. And you have a site beautification project, which is planting this vegetation, which looks better aesthetically, but also does something scientifically, which will help reduce the negative impacts of dust pollution for the local village that was being impacted by it. So yeah, you say, okay, well, dust can be reduced by 40%. It's not solving the problem, but if you have a chance to be affected by dust by 60% or 100%, clearly being affected 60% is going to be a significant impact to your health. So you're not only helping implement the E component, but also the S component, the social component of ESG.
Thank you, colleagues. Another question to Altina Almas representative. Abro, это к вам вопрос от Олены Бондаренко. You mentioned Altina Almas' new commitment to ESG. Could you share a bit more about what your plans and current work are in this area?
Okay. So I should answer on English, or I can speak in Russian.
Russian's fine.
Okay. Так, Алена, да, как я сказал до этого, в 2020 году была принята вообще общая идея, а в 2021 году она началась воплощаться в жизнь, и Altina Almas взяло направление по развитию по принципам ESG. Ввиду того, что, давайте будем говорить честно, да, и скажем, если в западном мире понятие ESG, наверное, всесильно уже используется в разных отраслях жизни и экономики, то в Казахстане, скажем так, в постсоветских странах это понятие довольно-таки новое, модное, и я хотел бы отметить также тот же факт, что не все, наверное, до конца понимают, да, что такое ESG и как с этим жить. Опять-таки, я хочу отметить, что это мое сугубо личное мнение, да, вот, и, скажем так, в такой вот среде, где еще, скажем, вот эти понятия до конца не созрели, нам приходится сейчас, наверное, изучать вместе с остальными коллегами из других отраслей, да, и банковский сектор, и производственный сектор, вместе изучать, что это такое и как с этим жить. И я хотел бы отметить, что на сегодняшний день в Казахстане имеется очень много разных площадок, где мы можем позволить себе вот изучение всех этих вот нюансов по части ESG. И, конечно же, по, скажем так, полученным нашим этим знаниям, да, по изучению лучших мировых опытов, мы в Алтын-Алмазе пытаемся воплотить, скажем, внедрить, да, те принципы ESG, которые, будем так говорить, мы можем осилить на сегодняшний день. То есть вы, наверное, прекрасно знаете, что, скажем, если даже брать часть только E, да, environmental, то она состоит более чем, если не ошибаюсь, 140 пунктов, кажется, или 135 пунктов, которые разделены на различную тематику. И, допустим, если взять наш один из последних, скажем, таких кейсов, то в рамках внедрения принципов ESG мы сейчас планируем провести научно-исследовательскую работу, опять-таки, по изучению негативного влияния производственных факторов на компоненты окружающей среды и биоразнообразия прилегающих территорий, то есть на всех наших проектах. Вот. Также, конечно, у нас ведется отдельная работа по части social, также у нас отдельная работа ведется по части governance. Работая в Алтын-Алмазе, у нас есть уникальная возможность, скажем так, разделить, наверное, вот эти вот ESG, да, то есть E отдельно, S отдельно и G отдельно. Почему? Потому что у нас в компании частью E, да, environmental, занимается мой департамент, департамент охраны окружающей среды. Частью S у нас занимается департамент PR, GR, HR. И частью G у нас также есть соответствующие бизнес-структуры, которые занимаются этим всем. Но при всем при этом также у нас компания недавно, ну как недавно, в прошлом году у нас образовался также департамент ESG, который, будем так говорить, собирает все эти пазлы воедино и, скажем так, выстраивает общую картину, когда мы можем уже в этой общей картине видеть, куда мы идем, к чему стремимся, какие у нас цели и так далее. Я ответил на ваш вопрос, Алена?
Да, да.
Да, спасибо большое, Абурой. Я очень рада, что такой комплексный подход у Алтын-Алмаз. Pioneering компания, да, по региону, и надеюсь, что дальше будет развиваться больше и больше. Спасибо большое.
Спасибо вам, Алена.
Okay, I have a couple more questions. Мой следующий вопрос to Mr. Van de Quaterlet. Guido, you here with us? Yeah, I see here. Could you please give us some examples of nature-based solution for soil pollution? It's also interesting, you know, just
Well, for soil pollution, the most common practice is, of course, phyto, either containment or phytoremediation. And these are very common methods that have been developed in great detail over the last 20 years. An interesting new topic that we are exploring for soil pollution is the use of vetiver grass in mercury contaminated sites. So we have a trial in Indonesia where we mix mercury contaminated soil. We mix that with biochar to bind that, and it is placed in a depot, and vetiver grass is added on top to ensure that none of the mercury leaches from the depot. So this is a typical example of where nature-based solutions can be used for soil pollution. To a certain level, I think the tree wells can also be used if you have biodegradable compounds in the soil. It really just depends on the concentrations. At some point when the concentrations get too high, they have adverse effects for your vegetation. So these are the two main examples that I just from the top of my head I can come up with.
Okay, thank you. Thank you. And my last question to Brandon. Brandon, maybe this is the last question. How do you see your long-term vision working with nature-based solutions? Please give us a short summary.
Well, I mentioned that in my presentation previously, but in general, what I would like to do, what I'm interested in, is further developing the work with phytocapture, but using it more and applying it more towards urban environments, and also expanding it in the mining sector as well. We have a potential project which will be coming up. It hasn't been finalized yet, but potentially we'll be doing it with RG Gold at a area there next to the mining camp that they have. And hopefully there will be an opportunity to apply for a tender with Altin Almas for a few of their sites for the planting and modeling of vegetation there at a few other locations that they have mining operations. Also very much interested in trying to get a very good prototype design for the water-based, mine tailing, water-based, nature-based solutions. So looking forward to continuing the work with HIDO and Tau Foundation on that in order to get some good expertise and to be able to hopefully self-implement such activities in the future, and potentially expanding towards the research on nature-based solutions for soil contamination. So that's what I would say. And before we end, I also have another one question for Dora. Dora, are you there? Yeah. So Dora, my question for you is, what are some of the main, let's say, facilitating determination of a suitable place for a nature-based solution, and this is how it should be done, let's say by a research institute, or is it a combination of them? And then the second follow-up question to that is, who finances these initiatives? Has it been partnerships between public and private sector, or non-governmental organizations which are implementing them? So I guess those are the two main questions that I have for you.
Yes, so about the drivers or the motivation, I just heard yesterday a number that in Europe, 80% of the projects are implemented by public bodies, so city governments, national and regional governments. Many of the projects are this a little bit top-down projects where the city decides that something has to happen, and then it happens. We see very nice examples of bottom-up projects where the community decides to do something. Usually these are like smaller scale projects. So the large scale interventions are almost always happening as a combination of different actors, like national, local bodies working together, often with companies and so on. The role of research is crucial. So I think we see that even if the initiative is coming from a public body, there is really a need for researchers to look at the area, study it, do a proper assessment, how is going to happen, because we have a lot of experience in cities how to do grey infrastructure. There is no need for learning there, but here there is a component to find the best and most suitable solutions. What a grey solution, like a road building, is working in one city to another, independent from the climatic zone. in case of the nature-based solutions, the local factors are very important. So I think the role of research is crucial. About financing, again, because public organizations are starting, it's often happening that public bodies will be financing, but there is a lot of efforts are happening to involve insurance companies, financing organization, banks to finance such projects. That's why I mentioned in the last slide that this putting a value on nature, using market-based approaches, understanding different kind of payment schemes where we can value the fresh air, the nature, the biodiversity in the area, is something that we see that it's happening, maybe slower than it should, but the part of the financing should come from the market.
Thank you.
Thank you. Thank you for your questions. Уважаемые коллеги, на этом сессия вопросов и ответов у нас завершена. Мы уложились в тайминг практически идеально. У нас есть даже еще несколько, 4 минуты примерно. От себя хочу сказать, что как человек, заинтересованный в развитии науки в университете Нархоз, я очень рад, что этот проект состоялся, что он прошел с таким успехом. Это действительно успех. Есть конкретный результат, есть что показать, есть эффект для сообщества, для очистки воздуха. Он достиг заявленных целей. Поэтому я благодарю Брэндона, я благодарю Алтын Алмаз за участие в этом проекте. Я благодарю